Please don't snap off. Please don't snap off. Please don't snap off. Hello Internet, my name is Quinn, and this is Blondihacks. Silver solder comes in these super maddening coils that are tightly wound and impossible to straighten out and make it very difficult to get the silver solder precisely where you need without sticking your hand in the way of oxyacetylene or propane or other angry forms of fire. So to address this problem, I've made what I call the solder pen. This is kind of like a mechanical pencil, but for silver solder, and it's a great afternoon mini lathe project, or if your lathe is bigger, that's okay too. So let's go. Let me start with a demonstration of the problem that I'm trying to solve. So here I'm silver soldering a model boiler project. This is another series that some of you may be watching. And you can see me struggling as I try to apply a little additional solder there to a joint that needs some. I'm having to hold the coil at a weird angle because it's very springy, and then I try to straighten it and I can't really get it straight. And you know, I had a little better luck holding it with pliers, but still, this is all just very awkward at a moment when you really need things to not be awkward because there's a giant fire of death in your other hand. Here's the tool that I designed to hopefully help with this. It's a hollow brass tube, and there's two ends threaded in, one for 1/32 solder and one for 1/16 solder coils. And then there's a tensioning knob that goes in the side. I wasn't sure if that was necessary, so I'm going to try building this without it to see how it goes. The stockpile supplied me with these lovely two pieces of brass for this project. I've got a chunk of round bar here that I'll cut off a little extra long for the main body of the tool. And then I'll cut off a smaller chunk of this hex bar stock that I'll use for the two ends, just enough to make the ends and have something to hold onto in the chuck there. Starting with the round bar, I'm going to choke it all the way up in the chuck because the first thing I want to do is drill out the center. And so I'm going to face off the end, as is tradition. And my tool height's not quite on center there. I got a tiny little nubbin on that first pass, so I'll just correct that tool height a little bit and then finish cleaning that up. Now nubbin free, we can move on to drilling this out. Now my intention was to center drill this thoroughly enough that the center drill taper will be left over, and then I completely failed at doing that, but we'll come back to that and I'll explain why we need a taper there. But I'm going to start by drilling this out as far as I can from one end. The overall tube is about twice the length of the drill that I have in this size. So it's a very high aspect ratio hole, which is to say it's extremely deep for the diameter of it. And whenever you're doing a hole like this, you overwhelm the efficiency of the flutes on the drill. The spiral groove on a drill has a maximum rate at which it can evacuate chips, so once you get below a certain depth, you have to start pulling the drill out more and more frequently. So sliding the tailstock back like this is a very quick way to do that. Now I need to come back in with a larger center drill and get my taper back that I lost. And this doesn't work super well because you don't have the pilot anymore, but if you're careful you can kind of get away with doing this. You'll see why that taper is necessary in a moment, but in the meantime I'm going to mark the depth of my tap here. Just approximate is good enough for this. We need to tap some threads in there that are more than deep enough for the caps that are going to go in there. And then I bring in my spring-loaded tap follower and tap out that hole. Eagle-eyed viewers may notice that that hole just shrunk, and you're not imagining things. This is the drill that you saw earlier. Doesn't fit. How did I do that? I made the part again, because I drilled it the clearance drill size instead of the tapping drill size all the way through the tube. Whoops. Luckily, an easy part to remake, but there's no shame in making a mistake like that when you're a beginner especially. Just make the part again. Pulling the stock out now and squaring up the tool post so I can turn the OD, and for this I'm going to need tail support. So now you see why I needed a little bit of a taper around the thread there, just so the tail stock has something to hold on to. And now I can turn down the OD. This is primarily to clean it up. The diameter here is not super critical. I decided to go for a diameter equal to the distance across the vertices of the hex bar stock that I have, so that when the caps are screwed on it'll kind of look nice. So that's what I did. I'm checking the diameter in 3 places, not because it matters, but anytime you turn long stock, it's a good opportunity to keep an eye on the taper in your lathe and see if anything needs aligning. Now in with the parting blade and part it off to the desired length. And Yahtzee. This little stub can go back on the stock pile. We won't need it, or will we? Now put the body back in the other way with some aluminum shim stock there to protect it. It's actually slices of aluminum can, works great for this. And we're going to drill out from the other side to finish the central tube. Now, of course, when you flip something in a 3-jaw chuck, you lose your concentricity. So I'm introducing about 5 thou of error doing this, but this is just a big hollow tube and it doesn't matter. If this was something critical like a bushing for an axle or something, then you would need to use a 4-jaw to flip it around and indicate in the existing bore somehow, but not a problem here. Tube drilled all the way through and the other end tapped. Now I can pull it back out again, and I'm going to put the knurling tool in here, and I'm going to put a bit of a knurl in the center area there just to give you something to grip while you're unthreading and threading the ends there. Especially if you're holding gloves, this might be helpful. So I start by clamping it down just tight enough that the wheels are spinning, and then I put lots of fluid on there, and then I proceed to crank it down, and then I engage the power feed very, very slowly. Now I'm not the greatest at knurling, so don't necessarily take my advice, but that turned out okay. There's a little bit of double tracking there, so it's not perfect, but it's certainly sufficient for this. There's the body complete now, and I can move on to making the ends. It's looking pretty good so far. In with the hex bar stock now. I'm going to find the 0 on my chuck here, and I'm going to mark that side of the stock, and that's because I actually thought I was going to do these ends in 2 different setups, and the great thing about hex bar in a 3-jaw chuck is that it will hold its concentricity quite well if you put the same side on the same jaw when you re-chuck it. However, I didn't end up doing that, but I thought I'd show you that anyway. It's a good trick for working with hex bar stock. It's self-indexing in that way. In with the center drill now, and that's not just for the drilling, that's also creating the cone that you see there in the part in the upper right. So you want to go in more than you would normally do with that center drill. Next, I'm going to go in part way with an oversized drill. This is quite a bit larger than the 1/32 final hole that we want, and this is going to save me a lot of work because I'm reducing the aspect ratio of that tiny hole. So here's the drill we need for the tiny part. This is 1/32, or it's a little bit bigger than that, and I don't want to have to drill this hole all the way through because this would be a very tricky hole if I needed to make it as deep as the entire length of the coned part there. So I've left myself 100 thou at the end of the cone there, and I'm carefully feeding the drill in until I feel it touch. And then I'm setting up an indicator on the quill of the tailstock here so I know how deep to go. I need to preload this all the way up to the depth that I want because of course the quill's moving away from the indicator in this case. And then I can get some WD-40 in there and start drilling. Now the trick here is that my lathe is not running nearly fast enough for a drill this small. My lathe tops out at about 900 RPM without moving the belt. But I can get away with this as long as you're very, very careful with the feed. Just feed in a little bit, pull out clear chips very, very frequently. Gentle feed and then clear chips extremely frequently. I'm only going in about 20 thou at a time and then clearing chips. And you can get away with running it too slow. If I was going to make a whole bunch of these parts, then I would go to the trouble of moving the belt to get the lathe running as fast as possible. Now I can turn the OD for the thread there. And if I eyeballed this right, the taper there should end up pretty close to the OD there as shown on the CAD drawing. That cone is there to ease the transition of the silver solder into the tip as you're sliding it through the tube. I'll deburr that, and then I can come in with the tailstock die holder. The nice thing about brass, especially with a fine pitch thread, is that it's very easy to cut the threads, so I don't even need the Tommy bar here on the die holder. I can just hold it by hand and run that down. And then it's always nice to put a generous chamfer on the back of a thread. It makes it easier to thread that thing in and out, especially with something like these ends, which are going to be threaded and unthreaded very frequently while using this tool. Now I'm going to come back in with my parting tool, and I'm going to undercut the base of that thread a little bit. And that's to make sure that the ends seat down nicely on the tube. As you can see there, it doesn't quite seat. Anytime you turn a shoulder and cut threads on it like that, there's always going to be a little bit of a fillet left in that corner. So the goal is, as you can see here, to just kind of clear away that material so that there's no interference and the tube will thread on there. Now my original plan was then to part this off, flip it around, and turn the taper, but I decided to do this with a form tool instead. So I just moved the tool far enough down that I knew I would be well clear of the base of the taper. And then because this is brass, I can just push this straight in. It's very easy cutting. And in fact, this form tool is just my regular turning tool. The angle on the back of it there is a pretty decent approximation of what I would like. So I just push this in almost all the way through, not quite parting the stock off. And then I feed the tool to the right until the thickness of the remaining hexagonal portion is about right. And then I can finish pushing inward. You'd never get away with this in something like steel, but brass is super easy to cut. So once I'm happy with the depth of that hexagonal portion, then I can move in and back a little bit with the two hand wheels to finish off that cut while keeping the hex portion the same thickness. And if I did my math right on the drilling, then I should now have the tiny hole that we drilled exposed, and that looks good. Now on the second one with the larger hole, I didn't quite get it right. The drill didn't go deep enough, so that was easy to fix. I just put the drill in the Dremel and punched that all the way through. Okay, let's do some test fitting. So I got the two ends made. I'm going to thread them onto the tube, and I'll start by test fitting the small solder, the 1/32 coil there. And the nice thing about the small stuff is that you can feed it through the larger tip. So you can leave both tips installed in this case. That feeds through very nicely. And we'll try the thick stuff. For the thicker stuff, of course, you do have to remove the smaller end, but you can still use the end there for storage when you're done, so you don't lose either of the tips. And that works really well. Now, this tool is not super necessary for the thick coils, but, I was making it anyway, thought I might as well. It's really only the thin 1/32 coils where you can't easily straighten it by hand. So that seems to work well. Seems to be giving me good control, so let's actually give it a try. So back onto the boiler that I'm soldering, and I'm giving this thing a whirl. Now you can see that I'm still really struggling with it here. And it might not be obvious why, but I've got the solder pulled all the way out because I still can't quite get it to point the direction that I want. You can see me futzing with the length there, trying to get a better angle. I can't get the solder pointed the way I want, and it was frustrating, and I figured out why. It's because the solder rotates in there from the weight of the coil. So you try to line it up the way you want, and then the coil flops downward. This is bringing me back to the tensioner idea that I had in the original design. I thought that knob would be used to hold the silver solder in place longitudinally in the tube, but that turned out not to be necessary. However, I think it will serve to solve this rotation problem. So I threw the tube in the mill and centered it up and measured a spot from the end with the edge finder, and I pre-drilled this for a small thread, and then I tapped this. Now I used a fine thread here because the wall thickness of this tube is not enormous. I managed to get 2.5 threads in there, which is pushing it. You really want 3 threads minimum in any situation, but this will do, I think. Now it's time for that little stub we had left over to shine. This will be the perfect size for making that little tensioning knob. So I'm going to start with a simple turning to a shoulder operation. I'll turn down this diameter here to the major diameter of the thread that I used in the tube. For the length of this, I just kind of guessed I wanted something that could travel deep enough into the tube to trap the silver solder as needed. After putting the thread on that, and once again putting a nice chamfer on there to make it pleasant to use, I brought in the knurling tool to knurl this little knob. That'll make it much easier to use. Now you got to be very careful knurling this close to the chuck because these knurling tools do have a tendency to wander along the work, especially if your tool post isn't super tight and if the hinges and joints and things on the knurling tool are not super tight. So do this with caution. But that went well. Got a nice knurl on there. Now the secret to any really good looking knurl is to chamfer the edges after knurling because the knurling process pushes a lot of material to the sides. It's not a cutting operation unless you're using cut knurl wheels, so it tends to push the material around a lot. but a little chamfer on both sides really cleans it up and makes it look nice. So with that, I can finish parting this off now. And Yahtzee. Okay, there's my adorable little knob. I'll say at this point, if you're new to lathe work, making little brass knobs like this for all the things that you own is a great exercise. It's a really quick project that teaches you a lot of basic skills. So look for things in your life that have wing nuts or other hand fasteners and replace them with nice brass knobs that you made yourself. Quick test fit on the tube, and it certainly seems to thread in there, so well, let's see if it actually functions as desired. With the silver solder in there, I tightened the knob down all the way, and that didn't work at all. Yeah. Remember how I guessed how long that thread should be? Well, it was too short, so I actually took some time and measured it and realized it needed to be about 40% longer than that. So I made it again, longer this time. Now tighten it down, and that is rock solid. That's just perfect. So that, I think, is going to do what I need. The resemblance to an airbrush is entirely accidental, but this gives me really good control over that squirrely coil of silver solder. Back onto my boiler project, and I can say that this thing is working great. It's giving me really good control and get that silver solder in there where I need without getting my hand too close to the heat. Very happy with how this thing turned out. As I said, this is a great mini lathe project if you're looking for one, and the drawings and 3D models are on my Patreon as always. And if you'd like to support the channel, go ahead and check out that Patreon for that as well. Thank you very much for watching, and I will see you next time.